Java program until 2 years ago, and I enjoyed it actually. But at that time, I'd like to make something else. I have done Java for many years. I thought I start to dump down. I need some fresh spirit, right? And at that time, I had this nice title of IBM Distinguished Engineer. And once I told IBM that I'd like to work for Microsoft, within 1 day, I became an extinguished engineer. That's really cool, actually, because that means you're out of the building within 1 day, which means you have time till the end of the work contract to do other stuff. So I had 3 months to learn. So what did I do during these 3 months? I watched recordings from the JS conference, actually. And I really liked them. I thought one day I want to be at this conference. But this conference is always sold out, right? So I learned you have to talk there that you can get this conference, of course. Now the problem is I had nothing, right? So I was a baby. Well, we are still a baby. So I needed at least 2 years to get some material to talk about. And I hope today I have enough material to talk about. So what I did in this last 2 years, now I built a small team in Zurich. In good Microsoft tradition, we have feature teams, now with testers and program managers. We are now 8 developers. And our focus is, and that's what I found, the challenge that hoped to stop my thumbing down. We work on online developer experiences. So the idea is whenever you interact through a browser with code, we'd like to have components for you, right? So we have a toolkit of components that allow you to build coding experiences in the browser. And I can show you some of them which are shipping today, which you might use or not, right? So for instance, when it comes to team software, right, we have diff engines that show you diffs. We have the TypeScript Playground. At this point, I'd like to ask, how many of you have heard of TypeScript? Excellent. How many of you have played in the TypeScript Playground? I hope we fixed that today. How many of you use TypeScript in a project? We work on that. So the good thing is now TypeScript has been open sourced last October. So it's really TypeScript plus the language service has been open sourced. And I think I highly recommend try to play with the TypeScript Playground to learn what this language has to offer for you. I think it uses some dirty words like classes, modules, and even interfaces. 3 dirty words. But the goal is really to reduce developer stress. And that was my passion since I started writing code, right? I like to reduce the developer stress. That's why JUnit happened, that's why patterns, that's why clips. Now we want to liberate developers to have fun coding. So the TypeScript Playground is yet another component that is built on our stuff, okay? I will show you later briefly. It's probably one of the most powerful playgrounds with refactoring support and all kind of good stuff. On Azure, when it comes to script editing, we are used. And for that, I'd like to give you a quick demo. That's the one which uses most of our components, which uses even a workbench that you can do coding of an app that can that you can put into the marketplace. What you can do, and that's pretty cool, for Office 365, and that's the only time I do some Microsoft product stuff. But what you can do is you can write extensions for Excel or Word in HTML5. Okay? And for instance, here I have written one which allows me to bubble some stock quotes, right? And that's the HTML widget, which is an extension. I say bubble, it will go to the net and show me all the stock quotes. That's okay. A dangerous exercise because it might be negative, but it's not too bad today, huh? It's good. So anyway, so that's what you can do. But the point is not that. The point is you can use HTML5 technology to do that. And the point is to try this out. You can do it all in the browser, right? That's the point. That's the scenario. Getting started, you want to try something. You do it in the browser, deploy it. If you like it, you can upgrade to the full IDE. And I can quickly show you what we can do in the browser. OK. confused, but that's fine. That's not it. That's PowerPoint. Come on, don't drive me nuts. Here we go. Well, okay, it's a little bit peephole view, but at least it's big enough. So you see now that's the workbench. It uses many of our of the toolkit of developer components. And this shows this app is really HTML5. It has an HTML page which loads several scripts, which has some script logic. Right in the script, I have normal stuff like code validation. Come on. Yeah, you see squiggles, all this stuff. You have reference searching. Who uses this stuff, right? You get it in place. You have refactoring. It's really challenging to do it in this tight resolution. But you see you have refactoring, all this kind of neat stuff. You have navigation help, and so on, right? You can navigate to stuff. So it's pretty rich, right? It has outlining, steps to stuff, right? Things like that. So this just to show you, right? It's pretty rich experience. So we say even for getting started experience, you want to be rich and you want to have a good coding experience with all the comfort, develop comfort you use from a browser. So enough. That's kind of the background. Let's go over and talk about a little bit what's behind it and how we grew into it. And our journey actually started 2 years ago, and we have grown in 3 stages, right? And the challenge is really how to become bigger and bigger. And the approach we try to use is what I would call extreme, triple extreme programming, right? Which means we don't use some technology until we really need it, until it really hurts, right? We knew from the beginning, yes, there's required.js, there's AMD, which is cool, but we want to lean back and say, let's wait till we really use it, and then we dive in, right? You want to feel the pain and then feel good afterwards. So, and that's the 3 stages. Now we have kind of small when we grew quickly to 50,000 lines of code, 100,000, and today we have 200,000 lines of code, which we wrote ourselves, plus test code with all the libraries, right? This goes much higher. What I found interesting, for each of these stages, we have some patterns that were relevant to us. So yes, I confess I cannot fully get away with patterns, right? In the smallest stage, we're really concerned about modules, classes, interfaces, promises, right? How you manage callbacks. Interface I will talk more about. That sounds a bit strange. But interfaces are a powerful way to tell others what you expect. And in particular, it helps you define the shape of things. And that's what I will show later. Modules and classes, every project has to think out which patterns they use for that. In the small stage, what is interesting, we only use about 10% of TypeScript because we had some concerns, right? We were the first adopters of TypeScript. While we saw the promise, we were skeptical that we'll lose the goodness of JavaScript. Right? As I said, I transitioned from Java. In Java, one technology we developed was we called JDojo, which was a Java front end to the Dojo widgets. And while I liked it a lot, in these 3 months, right, that I learned all the stuff this JavaScript community produced, I learned I really don't want to have a layer in between, right? I want to program as close to JavaScript as possible, right? I want to throw out closures, whatever. So for this reason, we were a little bit concerned. And in particular, our hardcore JavaScript members, we were 3 in the beginning, they said we were highly skeptical, right? Why do you want to do that? So we started very slowly. Then we gradually ramped up. At this point, even after 1 year, we had skeptics. So our execs asked, why don't you go to 100% TypeScript? I say, well, lots of blah, blah, but typically, 2 of my developers just resisted. They didn't want to do it because they still thought JavaScript, F5ing, and so on is faster for them. Interestingly, right, we see today we are to 100%, which means these 2 hardcore guys, they transitioned. And I can show you a little bit what's the story that led to that. So other patterns, in the medium size, AMD, lazy loaded contributions, components, dependency injection, which is really a Java thing. I thought I will never use that. I hope I can rationalize why we do something in a Java world to get to better testability. So I wonder, how many of you know TypeScript? Okay, so I want to do 2 minutes, quickly show TypeScript in action, and then go on. Okay, quick walkthrough. It's in the playground. You can all try it out. The point is left TypeScript, right JavaScript, and the point is no, TypeScript is very close to JavaScript, right? That's what's important to us because, as I said, we don't want to have lots of layers in between JavaScript. You want to appreciate the full power of JavaScript. So quickly to show that, TypeScript is just JavaScript, right? If you see that, it's almost the same code. That's just run to the TypeScript compiler. It adds optional types, right? You can type thing here, and the cool thing is it does type inferencing, which means you don't have to type everything because it's really smart. And from a return value of a function, you'll infer the type and so on to make it easy for you. And many other nice tricks. It has classes. Again, very similar translation, right, to use prototypes with a closure. And as I said, you have all the coolness in this playground. You can do refactorings, IntelliSense, all the stuff that I showed before because it's the same kind of component that we use. You can use a multi-cursor and whatever you want. Right. Okay. So classes, and of course there's modules. Didn't like that too much. Okay. The modules. And actually, it's our own editor, right? So you see it around corners. That's the sign that is our code editor. We had, for various reasons, we like code mirror A's and so on, but for various reasons, we had to write our own. So, but you have modules, right? The modules follow the standard module pattern. You have a closure and a module object. It captures what you export. And as I said, TypeScript is really close to JavaScript, and you can even debug at the JavaScript level if you use TypeScript. But still in the beginning, I had the skeptics in my team, as I said. So let's go back to that. And one interesting word I mentioned is interfaces, right? So I think kind of emulating some interfaces in JavaScript in normal ways just doesn't make sense, right? Because interfaces are really something more at the type before you run things, to express things. And one of the wisest sentences I made, I guess, in this Gang of 4 book was I always program to an interface, not an implementation. So interfaces I always like. What's interesting in TypeScript, interfaces are much richer than just what you see here as a way to define the shape of a class, right? That's a typical interface to define the shape of a class, which signatures it does have. It's still very useful, right? It's very useful because it allows me to check whether an implementation conforms to a particular interface. And we have caught many stupid bugs thanks to interfaces with this capability. The good thing is interfaces are very powerful to define the shape of things, right? So if you have an option or an option bag, an object, you just can describe the structure easily through an interface. And to make that easy, you can say what's optional, what's mandatory. And we also use this a lot for describing JSON structures, right? If you serialize JSON structures from the server to the client, we have a TypeScript interface that describes the structure, what's optional and mandatory. When we get the JSON object after the parse, we cast it interface. You have IntelliSense to navigate through the JSON structure. It's pretty powerful and nice. Interfaces can also express and can be invoked, which means you can also define the signature for callbacks in a compact way, right? So that says you have a measurement callback has the signature. Or you can also index them. You can define how you access an object, and what's the type of the indexed access, is a string or a number, then you can say what you return. Again, to the benefit, once you do that, you get IntelliSense and rich coding support by the tool because the tool knows what, at a certain point, what the type is. And very important, you can use interface to describe the shape of existing JavaScript code. And that's very important because you want to have tooling for jQuery, Knockout, whatever, all the cool libraries that the community produced. Actually, I must say one thing at this point. These 3 months that I had time to really get into JavaScript, the transition from Java to JavaScript was my hardest language transition. Right, I transitioned from C++ to Smalltalk, from Smalltalk to Java. Now from Java to JavaScript, that was the hardest one. And the reason is because the JavaScript community is so productive, right? They produce Node.js, they produce libraries, interesting patterns like the model view control, model view pattern, and so on, right? So this was really what made me kind of swallow a lot to get up to speed. But it also makes it very clear you need to have a way to describe all these existing libraries. Otherwise, you don't get the coding comfort that I want. Because one thing I want to keep from Java, I want to keep the coding comfort I had there. Right? I want IntelliSense, I want refactoring, I want to find references. That's just, I didn't want to lose. So now, how to use that? And a nice example is to use that for jQuery. So that's kind of another playground, right? Once you have this toolkit of coding components, you can produce playgrounds as you like. And this playground shows on the left some type definition file that just describes jQuery. On the right, the sample of jQuery code, which should kind of, it's a nice play, right? On the left, you can add type definitions, and then on the right, you can experience how richer your coding experience gets, right? Like I can do the dollar stuff, I get IntelliSense. And we all know the nice method chaining you can do with jQuery, right? And so on. And that's thanks to all these type definitions on the right. And jQuery is very rich when it comes to coding comfort, right? They use lots of optional stuff. Like, for instance, here, that's the interface to describe the Ajax settings. You see lots of stuff is optional, but you can still express the structure, get IntelliSense for it. Promises, right? The promise, the consumer, the deferred aspect, which is the provider of the promise. It's all captured as interfaces, and once you do that, you get this powerful IntelliSense behavior in the tool, which would be very hard to do otherwise. And let me just see how it's done, right? jQuery static captures the dollar, what you can do on the dollar. And one important thing you can do on the dollar is all these accesses through a selector, through an element, through a function, and depending on different things happen. And this all can be expressed through interfaces, right? Okay. So if you have done that, what the powerful thing is, you can describe these libraries and you get rich tooling support. Now, what's even better, there is a community now that does that. Okay? And the cool thing is, there's a whole project on GitHub that does these type definitions for all the libraries. Right? This is definitely the type library on GitHub, and it's very active, and almost for any JavaScript library, you will find corresponding type definitions. And it's very interesting to look at them because it really helps you to expose what actually do these libraries really do, because you get lots of insights when you see that, and you get much more insight than reading textual descriptions, right? Because it's really in the code at hand. Let's do the next step. So we have grown up. We have used TypeScript modules classes. We have used promises. I cannot go in details which version we use. The problem is there are many versions of promises, so you have to pick one. We picked one, and of course other teams pick other ones, which we have to fund then when you combine the code. We go to the next level. We grew up to 100,000 lines of code, and we felt we're not healthy anymore, right? I always like to this metaphor of code fitness, right? When my code is fit, I can run fast. When my code isn't fit, I get slow. And we felt at 100,000 lines, we're not as fit anymore because we cannot run that fast as you want. So what were the pain points we had? Well, the long list of scripts. Peter Higgins showed that. We had the same problem, right? Not only have to manually this long list, you have to also have the right order, and so on. Something is wrong here. Dependencies, big problem, right? So module pattern makes you feel like you have modules, but it's a very weak way to express a dependency, right? Because a module is just an object, and I can easily add a property. They're always open. I can contribute to a module from anywhere without any constraints, right? So, and one of the things we noted is that our JavaScript was rotting over time. And the dependency graph looked really messy. Actually, this is a comment I saw in a mail from yesterday, which is not from our project, but this shows, right? That's a problem, right? Managing dependencies in a large-scale project, JavaScript project around 100,000 line, that hurts. So you need to do something against it. Last but not least, we had also growing pains because even though we had 100,000 lines of code, we don't want to load them on startup, right? When you have tools, you have lots of optional stuff, right? When I don't edit a C# file, I don't want to load the C# related code, right? I want to load it only when you actually do something with C#, for instance. So we had this problem, though we had the eagle loading our network tab looked really ugly. When you see that, that's also a good health exercise. Look at your network tab when you start your application in the browser. We looked really ugly, lots of requests, lots of data transfer, very unhappy. AMD to the rescue, we saw it already. Dojo did it, one function rules it all. It's a very nice spec, actually. It's a short spec, one function, but a very rich one. So in order to understand it, we had to implement our own AMD loader. And it was really good, and we still use our own loader because gives some flexibility, but it's conforming to the spec. So what does TypeScript offer to that? What's nice about TypeScript, they can abstract kind of the details of the module definition from you. Basically, in TypeScript, you can write an external module statement that gives a path to the location of the module, and then when you actually transpile it to JavaScript, then you can say which module system you're using, and depending on that, it will generate different require statements or define statements for you. So that's very nice. And we found that very handy because this define statement can become hard to manage when you have 20 imports, right? You have to count all the time, and TypeScript makes it kind of nicer. But still, we use both at time to time, right? We convert our code in JavaScript, and in TypeScript, we worked intensely with the TypeScript team at this time to get kind of this support for the module systems in so that we can really kind of use them with comfort for what we did. The other challenge we have is you want to support a la carte consumption, right? So that's really nice with AMD because with AMD, the code knows its dependencies. And we know we get many external customers, and they want to have different pieces from our toolbox. So the nice thing with AMD, you can pull out anything, and thanks that each thing knows its dependency, you know we get everything you need. One missing piece we found was CSS, right? If you want to have self-contained modules, you want that the CSS, when you pull one component out, comes with it as well. So for this reason, no, but AMD allows you to support that too. So we had an AMD loader plugin for CSS, which we also can hint to TypeScript transpiler using a pragma that tells, actually, in this class uses the CSS class, which includes the images and so on. And the cool thing about that is really have these self-contained modules, right? You can just pull them out. If you don't want a component, you can drop it. You will not get it at all. OK, that's always my favorite slide in Eclipse. The problem is how you scale up. You have lots of code, and the pattern here is lazy loading of contributions, right? People contribute to you, but of course, just because they contribute to you doesn't mean you want to load it all. And what did it wildly different at this time than in Eclipse? We still use this contribution pattern by saying you split a contribution in two parts. One is the top of the iceberg, the visible part. And the visible part is what you always load, right? The one which you need so that it can function and deal and play as if the component is loaded. And what we do is we use JavaScript to describe the component. JavaScript is very powerful, so we didn't want to use XML. And we like JavaScript much better because of IntelliSense, validation, whatever. So here we describe the component. In this case, it's the C# language mode, language service. It says load it when you load a file of type C#. You describe which module to load and which class to instantiate, right? That's how it works. And that's kind of the tip of the iceberg. And once a file of this type is loaded, then the code below is loaded thanks to the AMD require call that allows you to load code dynamically. And we can then load the lots of code only on demand when needed, right? This is how we can scale up. And we do it in many places, right? If we have views, different views, we only load views when they the first time become visible. We don't load them up front. And thanks to the self-containers of CSS and everything together, everything comes with a contribution in one swoop. What was interesting after this migration, it was hard though. I must say this took us 2 months to migrate our code because, well, yeah, it was a little bit, the dependencies were messy. We had to remove many cycles. We had also to organize the directory structure, which I find is a common problem in a large JavaScript project, right? Directory structure is kind of random. But the good thing is afterwards, and kind of Alex is our hardcore developer, he says he really feels like fresh showered. And that's a good sign. And we also felt we can run fast again. Our fitness was good again, and we can go on, right? We have no more cycles, no more globals, and everything with explicit dependencies. You feel good after that. Well, they have still grown further, right? As usual, and in particular if you do software tools, they will always grow. And now comes the next step to 100% TypeScript. What did we do there? So we are into other limitations. The first one was our hardcore JavaScript programmer felt he really starts to feel like writing JavaScript code in large program feels like carving code in stone. But he wrote the editor, and he really felt when he wants to refactor in JavaScript, he had a hard time. And he had to refactor a property called ID. And he just said, I die unless I really know where this is used precisely. So he asked me, can I have this? Can I have time to convert the editor to TypeScript? And in this way, we got from 50% to 100%. So this was the growing pain, right? That we lost our agility to change code. Tooling slowed down because we transpile lots of code, 200,000 lines, even a fast compiler takes a while. And you also find this coupling thing. Our testability went down because some of our high-level objects, they have dependencies on services. So when you write the test, you have to instantiate lots of other objects, right? And this is really kind of this Java pattern of dependency injection that allows you from the outside to inject different implementation of services so that you control what is instantiated, and you can also get a lot of configuration flexibility. So, okay, that's a slide. So just to get a feel, the cleanup from when we went to 100% TypeScript, we got a kind of a speed of 300 lines of code per hour, which is not a lot. But it's explained because you really clean up stuff, right? You describe objects, you add interfaces to capture the structure you use. And even a highly disciplined developer, he found, no, as he just uses objects in JavaScript, he uses different formats, and he wasn't consistent. But once he could express the structure, the objects they had, he flows around his system, he could make it consistent. That was a cool thing. Componentization is another thing, right? At some point you say, well, we don't want to have all the code treated like it's our source code. I just work with it. I use it, but I don't need to change it, right? And you need to have some way of componentization, which means you treat it as a binary component. And fortunately, TypeScript supports that. And this is how we use the TypeScript compiler, for instance. We treat it as a binary component that we just slurp in as JavaScript code without having to recompile it every time. And there's a compiler option that allows you to generate these declarations, the interfaces that capture the shape of the classes in this component. Dependency injection, I don't want to talk too much about that. It's something that helped us because we found we'd use kind of some common services and we don't want to instantiate that. So we identify the services, create interfaces for them, and then we inject them into the code for some high-level objects. Last point, just as I speak, the TypeScript team is actually working eagerly on getting the 0.9 release out, which is a very important milestone for them towards 1.0. And the big achievements in this release is they added generics, which gives you even more power to describe things. Like, for instance, you can describe the map function, right? The map function is interesting because you pass in a function which returns a value, and the resulting type of the array depends on the return value of the function. And now you can describe that in TypeScript, which means you get richer intelligence even in this case. And the compiler has a new architecture which should make it scale better for very large projects. So our retrospective, we were skeptical initially, even so we were also Microsoft. We were very skeptical because we didn't want to lose the JavaScript feel. We didn't want to use the JavaScript closeness. But in the end, I think it paid out for us. We feel we are fit again. We can run fast. So we would do it again. And in fact, this time, we would start with TypeScript and AMD from the beginning. So that's our conclusion. And my point here is really, this is open source. Give it a try. It helped us to increase our developer comfort. I hope maybe it helps you too. OK, thank you.